All right, students, we're going to go ahead and fill out our vocabulary worksheet. It's called Function Vocabulary. And so we're going to take a look at some of the common terminology we'll be using throughout the pre-calculus course. The first term we're going to use is called increasing. A pictorial example looks like this. As you can see, it's a curve that increases from bottom to top, and it can look like this or it can look like that. The common language you use for increasing is it goes up from right to left. The mathematical definition is a little bit more sophisticated and a little bit more verbose, and it is read as f of x is increasing on an interval when for any a and b in the interval, if a is greater than b, then f of a is greater than f of b. Our next word is decreasing. It looks similar to increasing, except it curves down. And the common language used for decreasing, it goes down from left to right. And the mathematical definition, kind of similar to the one for increasing, except f of x is decreasing on an interval when for any a and b in the interval, if a is greater than b, then f of a is less than f of b. Maximum is our next vocabulary word, and it looks something like this. And if you notice, there is a point on this graph right here, that point. And if you take a look at the picture and the arrow, just think of a hill and how once you reach the top of the hill, you're at the highest point you can ever come to. The common language is relative high point. The mathematical definition is a function f of x reaches a maximum value at x equals a if f of x is increasing when x is less than a and decreasing when x is greater than a, and the maximum value is at f of a. Minimum, similar to maximum, except that we have a valley, and that point right there that I just marked is at the bottom of the valley. The common language is a relative low point, and the mathematical definition is a function f of x reaches a minimum value at x equals a if f of x is decreasing when x is less than a and increasing when x is greater than a, and the minimum value is f of a. Asymptote, one of the most important words that you're going to be seeing in pre-calculus. The pictorial representation looks like this, and as you can see, there are two dotted lines. If you notice with this dotted line that I'm marking first, that is a horizontal asymptote. We'll break that down more as we come towards the unit. And then we have another type of asymptote called a vertical asymptote. And again, when we get to that point in pre-calculus on that unit on asymptotes, you'll know more about them. The common language is it's a boundary line, and this boundary line is where the graph will not cross those two dotted lines. The mathematical definition is a line that a function approaches for extreme values of either x or y. All right, we're going to take a look at our next vocabulary word. It is an odd function. What does the picture look like? Well, it looks like this. And as you can see, that an odd function will contain that point I just marked there. And what is the common language? Well, the common language is a function that has 180-degree rotational symmetry with respect to the origin, or it looks the same right side up as it does upside down. So if you turn the picture I just showed you 180 degrees either clockwise or counterclockwise, you will get the same picture as you started with. The mathematical definition is a function is odd if f of negative x equals negative f of x. And we will use that mathematical definition more in class as we come to explicit functions, where you're going to be asked to determine if a function is even or odd using algebraic manipulation. An even function looks like this, and if you notice, there is a mirror or line of reflection, which is the y-axis. So in other words, if you are to fold that this graph across the green line, if you were to fold it where the green line is, both pieces of the graph will match up. The common language is a function that has reflectional symmetry with respect to the y-axis. And the mathematical definition is a function is even if f of negative x equals f of x. Again, when we start dealing more with explicit functions, we'll be able to see if a function is even by using algebraic manipulation. In behavior is our next vocabulary word, and this is what it looks like pictorially. If you notice, there are two arrows here, and we pretty much consider the tail ends of every graph when we talk about in behavior. What is happening with the tail ends? Where are they going? Where are they headed? The common language is whether the graph points up, points down, or flattens out on the extreme left and right of the graph. The mathematical definition is as x values approach infinity or negative infinity, the function values can approach a number, which is f of x approaches n, or it can increase or decrease without bound. This is referred to as the functions in behavior. Our next vocabulary word is jump discontinuity, and this is what the pictorial representation looks like. The common language is a point that jumps from one function to another, and the mathematical definition is the limit as x approaches c from the left side of f of x does not equal the limit as x approaches c from the positive side of f of x. We'll talk about this more in detail as we get into the unit on discontinuity. And also we're going to focus on removable discontinuity when we talk about jump discontinuity, which is our last word. There's the pictorial representation. The common language is undefined in f of x, but is defined in g of x. And the mathematical definition is the limit as x approaches c of f of x does not equal f of c. This is the function vocabulary that we're going to be using throughout the course. Please make sure that you have this information written down from this video, as we will be dialoguing about all of these vocabulary words in class. Thank you, and you have a great day.